All right, let's take a look at the symmetric group on 3 elements and show that there are 4 elements satisfying x squared equals e and 3 elements satisfying y cubed equals e. So what's the symmetric group? Here's our formal definition here, but we'll show it with an example. So here are the 6 elements of the symmetric group on 3 elements. So that's a little confusing, so I'm going to start calling these little guys objects here. So what I've circled is an element of S3, which is going to be this mapping that we'll get into. And let's call these 1, 2, and 3 on the top row here objects. So here we think of this 1 as being in first position, 2 is in second position, and 3 is in third position. And what an element of S3, which is the whole map circled in blue, does is it rearranges or permutes the elements, the objects. So here object 1 is going into second position, object 2 is going into first position, and we've labeled them so that we remember where they came from. And then object 3 just goes down. And what we call this bracket 1, 2 is called cycle notation. So if we look at this example over here, we can see why we call it cycle notation. So what the 1, 2, 3 does is it tells us where 1 goes. So 1 goes to the second position. And then we say, well, where does 2 go? 2 can't go to the second position because these are injective and onto mappings. So 2, we just follow our cycle notation, goes to the next number, which is the third position. And then where does 3 go? Well, 3 goes back to the start of the cycle, which is the first position. So that's how to read the cycle notation. And then you'll notice in our 1, 2 example that if the number isn't listed, like 3, then it's unchanged, right? Anything that's not listed is unchanged. And we see that in what's the identity element. So in the top left here, we have the identity element, and no numbers are listed in our cycle. Well, that's because everything just goes straight down. Now the question's asking us which elements, and there's these 6, squared get back to the identity. And this is the identity in the top left. Well, what does it mean to square an element? Or what would, for example, e times another element look like? Well, we see from our definition, multiplication is just given by composition. You do one and then the other. You just do them in order. So to see what that looks like, we've squared all of our elements here. And if we're looking at the problem just says, hey, which one of these are the identity? Well, for any element to be the identity, again, this is a map itself. This is an entire mapping. For this mapping to be the identity, it needs to send 1 to 1, 2 to 2, and 3 to 3. And we see here that this map does that. 1's in first position, 2's in second position, 3 is in third position. And so to figure out which ones squared give us the identity, we just look at which ones give us everything in order, which is pretty easy to see, is we get these guys. So these 4 elements are the elements squared such that they equal the identity. And you'll notice that the elements that work are the identity, which is expected based on the group axioms for the identity. And then the other 3 elements that work are the ones that are 2 cycles, or simple transpositions, we also call those, right? And that makes sense because when we look at the 3 cycles, if I'm moving 1 to 2, how is 1 going to get home if I repeat this? When I repeat this, 1's going to go to 3. And then I need another composition to get 1 back to 1. And so moving on to the second part of the problem, what are the 3 elements that satisfy y cubed equals e? Well, the identity is definitely going to solve y cubed equals e. The identity to any power is always going to be the identity. So that one definitely works. And now let's look at our 3 cycles here. 1's going to go back, 2's going to go back, and 3's going to go back, just like this. And the same thing here. This is the cycle in the reverse order. It goes back like this, and we're going to get 1, 2, and 3. So those are the 3 elements such that y cubed equals e, and then the ones checkmarked in blue are the x cubed equals e elements. Thanks for watching this video. I hope you enjoyed it. Make sure to subscribe so you don't miss out on future videos. And if you have a question about this problem, or if you'd like to request a solution to a different problem you're working on, let me know in a comment below.